Insulation is helping us go places we could never go before, including extreme environments. When designing insulation for the International Space Station, scientists were confronted with a set of problems found nowhere on Earth.
We don't have the benefit of Earth's atmosphere when we're in orbit. And not having that benefit, we're exposed to much more extreme environments. In the same orbit, we can see temperatures in excess of 250 degrees Fahrenheit while we're in the sun, while a few minutes later be exposed to conditions that produce environments less than minus 250 degrees Fahrenheit. And we go through this 16 times a day, every day, 365 days a year.
Scientists had to rethink the entire insulation process when designing the station. The vacuum of space allows only for radiant heat transfer, usually in the form of energy waves emanating from the sun. Earth's atmosphere prevents it from being overheated by these waves. But the space station, without such protection, is subject to the extreme temperatures brought on by solar radiation. The scientists had to come up with an insulation that would safeguard it. Their solution was a multi-layer insulation, or MLI.
MLI serves two purposes. The first is to reject or reflect a lot of the sun's energy, and the second is to entrap heat that's generated internally. And by doing this, we can moderate the extremes that we see on orbit.
One of the key components of the insulation is the plastic.
On that plastic, we apply thin layers of aluminum, and that aluminum is very reflective.
The mylar is protected by an outer layer of fiberglass fabric. This layer strengthens the insulation blanket. The inner side is aluminized to prevent harmful radiation like ultraviolet light. All the layers are sewn together to create a pillow-like blanket just 1/4 of an inch thick. When designing the insulation, scientists also had to make sure it didn't weigh too much.
We use very thin layers to make up multi-layer insulation. And the reason mainly is because of weight. The pressure shell of the module itself is about 1/4 inch thick on some of these modules, and that aluminum can be very heavy. Well, the last thing you want to do is add more weight to the space station.
Working in tandem with thermal controls inside the station, this advanced insulation helps to maintain a stable onboard environment. With a temperature of 65 to 80 degrees Fahrenheit, and humidity in the range of 25 to 70%. This is the future of insulation.